Hello, uh, my name's Matt Falkenhagen. I'm a software engineer at Google in the Tokyo office, and I work on Service Worker, which is what this talk is about. So, okay, so just kind of what I would like to, do in this talk. First, give a overview of Service Worker, so we all know like what the talk is about, and then go on to talk about how the project's going, our current status, our plans, and then talk about like why we think it's okay to pursue this feature. And in doing that, I'll talk about the common risks with a web-facing feature, things like performance and security, how those relate to Service Worker, what our story is for those things, and why we remain optimistic. So hopefully, by the end of the talk, everyone will understand, what a service worker is, and there'll be like a lightweight, venue for voicing, concerns or support or ideas of how to make the feature better. Okay, so let me just start with some context, like what the goal of this project is, like why we're implementing Service Worker. It really is about improving the offline story for web developers, which is part of closing the gap with the native app experience. So currently, obviously, a native app can work very well offline, which isn't really the case for web apps right now. Kind of the best story we have right now is using AppCache, which is this thing that it seems like everyone that used AppCache or uses AppCache just universally dislikes it. So I personally haven't used AppCache, so I can't comment extensively about what's wrong with it. But it's basically this declarative way to say like which URLs, which resources your site depends on. So you put these in a manifest file, and the browser can cache like the things you need, and that's supposed to make it magically possible to make an offline web app. But it turns out that that's not the case. It's too like inflexible and kind of magical a way of producing an offline web app. It's things like it's difficult to reason about when your offline content gets updated. It's hard to mix offline and online content. And there's some common pitfalls where like your manifest file itself, which controls your app itself, gets cached and it can never get updated. So anyways, yeah, Service Worker is kind of a response to our practical experience from AppCache and the new way to make offline web apps. All right, so let me just explain like, okay, what is Service Worker? So a Service Worker is JavaScript installed by a website. That means it exists offline. And it runs in a separate worker context. So the Service Worker controls like live documents, live pages, but it runs in a different context. So it doesn't share execution context with these pages. And so when one of these pages is visited, the Service Worker gets events about what's going on. So it's able to respond to these events appropriately, and it can do this even when it's offline because it's stored offline. So if you try to access a website without a network, the Service Worker can be running locally, and it can hear that you're trying to access this website and respond appropriately. So yeah, it's just a JavaScript installed in your browser. Okay, so just to get into more detail about how it works. So let's say you visit example.com, and example.com wants to register a service worker. So it does this using JavaScript, navigator.serviceworker.register. The first parameter here is the service worker itself, so myserviceworker.js. And then the next parameter is the scope, which is the set of URLs that this service worker is registered to control. So here I just put example.com/abc/wildcard. So what this means is when registration is complete, myserviceworker.js will run or it'll control any URL that falls in this scope. Okay, so registration is actually an asynchronous operation, but let's assume that it's finished, it's installed successfully, and then your browser navigates to example.com/abc/def. And obviously this falls in that scope of the service worker. So the service worker will run, or it may be already running, but anyways, it's able to intercept the request. And I'll go into what that means to intercept the request in the next few slides. But it's able to control like what the browser sees in response to this request. Not only that, but when the page loads, it probably makes resource requests to other pages or other resources. And the service worker also gets these requests and can respond to them as it wishes, even if these are to other origins. So it really like totally controls everything about example.com/abc/def. Okay, so what does a service worker actually look like? So it's this thing that responds to events. So it's basically made up of event handlers. The main one would be onFetch. So when the browser tries to fetch a resource, it will dispatch this event to the service worker. So the service worker here is registering an onFetch event handler, and it responds with event.respondWith and provides a response. In this case, it's just hello world, HTTP status OK. So example.com/abc/def will display hello world, and that's all the browser thinks is on that URL. And if somehow this site were able to make resource requests somewhere else, the service worker would also respond with hello world for that. So just a minimal example of a service worker. Okay, so here's kind of a more like practical example where it kind of shows the power of service worker. So here the onFetch handler is doing the same thing. It event.respondWith, but then it'll say fetch event.request. So fetch is this API that the service worker has access to that fetches what's you can give it a request and it'll fetch that. So if this completes successfully, basically what happens is it's as if the service worker did nothing. It's just normal, go to the network, get what's at that URL, and show it. If that fails, which means, for the sake of this talk, it means that you don't have network access, then the service worker can look in its cache. So the service worker also has a cache API, which is a persistent storage thing where you can store responses key to requests. So you can look in this cache for what's stored for this request, and if there's a match, it sends that instead to the browser. So what this is like basic fallback to offline. First try the network. If that fails, you get what you stored previously at some point previously for this request. Okay. Yeah, so that's basically like what service worker can do. It can intercept these requests and provide arbitrary responses to it. So let's kind of step back and look at what the implications of this are. So a service worker is able to mediate all network actions by the pages it controls. It also has access to this persistent resource cache, so it can put whatever it wants in these caches, and they persist indefinitely. It's also able to message and be messaged by all controlled pages using just post message, the standard web messaging APIs. So it's really this kind of intelligent part of the site installed locally on your browser. So it's really this thing that's able to do all sorts of things locally in your browser without without necessarily making network requests to the site. Okay, so yeah, that's what it can do. So like, what are some use cases of of this thing? So one is, as I mentioned before, basic fallback to offline, just using request intercept and the cache API. Another kind of approach to that is doing offline first. In this case, you would first show static or cached content before waiting for the network. So the service worker can immediately display like what it has, what it knows about the site, and it can be a better user experience. Like once you go to the site, you don't have to wait for network response. You immediately see something, and when a network response comes in, what you see can be updated to be live. Yeah, and then sort of around the same lines, you can have like a sophisticated hybrid of offline and online content. So something like if you were to make Gmail or a mail app, like a website, you can imagine like, oh, when you're offline, you can search what you have locally stored, and when you're online, you can both look at your local cache and also go to the server for like your entire entire store of mail, as opposed to what you have cached locally. Yeah, there's many examples like like a photo gallery. You probably store some snapshot of a set of photos, games with downloadable levels, things like that. And the last one is more like what APIs can be built on top of service worker, as opposed to like a use case itself. So things like sync and push, geofencing. There was a talk earlier today by Peter Beverlew about this stuff, so you can refer to that. But those APIs are built using service worker. Yeah, so those are some use cases of service worker. Okay, and there's also some important characteristics of service worker that I should call out to help understand more about it, what it is. The first one, yeah, I've covered. It's installed for offline use. Without a network, it can still run. The second one is it's actually quite ephemeral. It can be killed or restarted by the browser at nearly any time. So there's no guarantees about how long it's running. It can the same like service worker process isn't necessarily living between events that the browser sent it. The other thing is the default is to do nothing, which means if you register a service worker and it's like a blank file, just nothing bad happens. It falls back to the network. And if your service worker doesn't respond to event, it's just as if you never registered that service worker. That also means that for sites that don't, for browsers that don't implement service worker, like these sites that use service worker can still work. It's just as if there's no service worker. Okay, so like where is all this defined? There's a GitHub where a lot of the spec work is or basically all the spec work is happening, that I linked to in the slide. And also this spec is published in the web apps W3C web apps working group, the first public working draft, and it's also lives on GitHub, so you can check those out. Okay, I think that's what service worker is. So the rest of the talk is kind of talking about how the project's going, and risks or issues about service worker. But are there any questions about like what service worker is now, or should I just continue? Yeah. Oh, yeah. So the question was like, what does it mean to not respond to event? Yeah, so what I kind of meant by that is if you don't install like event handler, the browser dispatches the event. Like it should just be that the service worker doesn't exist and things just work. Yeah.
I've not heard of the ability to send multiple responses for the same request, or maybe I misunderstood that. The example was if you had static content and before the network responds, you might load the static content first, the cache content, and then while you do a network request, would that be separate requests? or would that be a single one with multiple
Yeah,
responses?
yeah. So the question was, how do you actually do like the thing where you show offline first and later go on to show the online content? Like, is that actually separate requests, or one, or giving multiple responses to one request? It's not multiple responses to one request. Basically, crafting your site and your JavaScript to take a request, give response to that, and then I don't know, later on, able to update the site to show new content. Yeah. Yeah, using something like post message to talk back to the page. Yeah. Yes.
So you said that the service worker can be built anytime. So we store the file states in service worker.
Right. So the question is, if the service worker can be killed at any time, can you store local state in the service worker? And you can use like persistent databases like IndexedDB, or you can use the cache API that's exposed to service worker. But you can't assume that, for example, global variables in your service worker script work. You basically shouldn't use global variables in your service worker because of this. Yeah. Yeah. So the question is, if the internet is not totally offline but very slow, is there an option for the user to choose to be offline? Or hmm, I don't think. I think you could probably do something like a timeout within the service worker script itself. So yeah, earlier I had this slide where if the fetch event fails, you catch the failure. I'm actually not too sure like in what circumstances fetch would throw an error, because the fetch API is actually also being developed now. But I imagine if you have the network and it's just very slow, you could probably do something like, I don't know, set a timeout, do the fetch, and when the timeout expires, you'd go ahead and respond with something like that. Yeah, yeah.
Fetch is supposed to return a promise. It's
Ah.
really easy to define timeouts on top of promises.
I see.
Auto-fail.
That's a good point. So yeah, the fetch API uses promises, and it's easy to tie a timeout to a promise. So yeah, that's how you do that. Yeah, go ahead.
On his original question, that sounds like a UA thing. Firefox had a thing you could force offline. I don't know if it still does, but at least at some point back in the day, it had an option to force offline, use cache or whatever. And so if an individual browser chose to, like Chrome, chose to offer such a choice, that'd be something that would interoperate with service worker, but wouldn't be service worker itself.
Okay, yeah. So Tab also brought up that it can be the part about trying to go offline can also be like a UA feature that some browsers may implement, but not necessarily intrinsic to the service worker. Yeah. Yeah.
Is it capable for inspect the response from the server? For example, if you are behind maybe some kind of authorization portal, yeah. So you aren't really online, but you got the response from the web.
Sorry, can you say that again? I was.
Here. Thank you. In some cases, you may got the response from the server, but it's not the really response. It is some kind of authorization page, maybe of hotel or so on. And or is there ability to inspect for service worker to inspect the response to make some kind of checks about content. So it makes a request. It knows that the response should look like, and it is not, it doesn't expect it, so it decides it is offline.
Yeah, so I believe the service worker can inspect this response that it gets from fetch. So, oh yeah, if it's the same origin, if it's the, yeah, right, yeah.
I think with captive portals that needs to be handled at the platform layer. You can't really expect individual web pages to deal with captive portals.
Okay.
But technically, a service worker could deal with a captive portal.
No, it couldn't because it can't inspect the response.
It gets man in the middle, so it's still same origin response. It can inspect that and tell that this doesn't look like what I think it should.
That often is a redirect.
Sometimes.
Okay, yeah. Let's take that offline. Yeah, because we have limited time. But yeah, thanks for the point, and it'll be on GitHub issue somewhere. Okay. Let me continue. So I'm going to talk a bit about how our implementation is going, current status and plans. So first of all, yeah, who's doing this? Who is the service worker, Chrome team? So what's that? Oh, so okay, yeah, I was nervous putting these numbers, but yeah. So Tokyo has a team, Cambridge has a team. It says 2 on the slides, but I'll update that to be 3. There's also people in Mountain View, San Francisco, and also like all the we made a conscious decision to like put the majority, almost all of our discussion on BlinkDev. So everyone on BlinkDev is also able to watch how the implementation is going. Spec work is being done by many people. Kind of the main people are Alex Russell at Google, Jake Archibald at Google, Junki Song at Samsung, and all the spec work is also open on GitHub and Web Apps Working Group, so anyone can participate in that as well. Okay, so what do we have in Blink now? So today's status, which is top of tree, kind of corresponds to Chrome M36, but a lot of this stuff might actually not be there depending on when the branch point actually was. But this is what we have now. You can do a minimal service worker, which means you can register a service worker and it gets events. We also implemented service worker.current, which is how a control document accesses its service worker. We have clients.getServiced, which returns to the service worker its control documents. And we also have post message between documents and service workers. So basically, you can register a service worker, it gets events, and the service worker can talk to the document can talk back to the service worker. So if you want to try it out, you have to put some flags in the command line, enable service worker, and the typical enable experimental web platform features. Okay, yeah, so what are we working on next? So we identified like things that actually must be there before shipping, and we're kind of targeting M37, 38, which is about a month or 2 from now, maybe something like that. But anyways, like what we absolutely need there are a useful subset of the web platform API. I'll go into like what that subset is later. Script persistence, which means the service worker is actually stored on disk. Debugging a service worker in the inspector, because no one's going to seriously use service worker if you can't debug it. So we definitely need that. Upgrading a service worker, so you have like a version of the service worker, but you updated it on your site, and you want the browser to pull in the new version of it. So that has to be done. Service worker lifetime management, the killing of a service worker and not running just indefinitely, it also must be implemented. And yeah, obviously, like performance security also needs to be covered, and as part of that, we plan to do things like writing a security fuzzer to find crashes, perf tests. The service worker also is only supposed to operate on HTTPS resources, and the service worker itself should only be a HTTPS. It's the service worker URL should be HTTPS only, so that also must be implemented. And that's part of the security story of service worker. Okay, so yeah, I said that we would ship, or we envision shipping like a vital subset of the API. So this is basically able to do the request intercept, so it can get a request and it can respond with maybe a string or a blob. We actually don't. We have no decision yet on which one's more important. So also the document should be able to access these service workers. So this is things like navigator.serviceworker.current, which might be renamed to something else. Anyways, being able to get like different versions of the service worker, like your current one that's controlling you, a service worker that's being installed, a service worker that's waiting to control you, and basically those should be implemented. Also, a document can use this when ready promise to wait to see, or not wait, but when ready resolves when there's a service worker ready to control you. So if a document wants to wait or know when that's available, it can do that. And also a simple kind of subset of the fetch API. So fetch API is kind of under development, like spec-wise. And we'll need to have like at least something that works before shipping anything. Okay. So yeah, you're probably wondering like what's not in that subset. So there's I don't know. These are just kind of examples of things that we probably won't get to in the first version. So things like the service worker calling update, which would run the update process for the service worker itself to bring in a new version from the site. The service worker unregistering itself. So like update is the browser side can do it, or the document that's controlled can do it, like during the registration step, as I have here, service worker upgrade, and also soft update, which is like this periodic. I think it's like 24 hours. Once every 24 hours, the browser can just spontaneously check to see if there's a new service worker script and update that way. Service worker.clients.reload all, which would mean that the service worker forces a reload of all the pages that it controls. We just decided it's not, maybe not essential for the first version. But yeah, these are just examples, and the subset will change as we discover what people that want service worker like really need. Yeah, and another thing to call out like as not likely to ship in the first version is the cache API, which is a quite big project, but the good news is it's polyfillable with things like IndexedDB, so we can provide a polyfill for that. Okay, so just in terms of like the time schedule, so today or I don't know, maybe when people come back to the office, we can remove the enable service worker Chromium flag. So what this means is that Chromium will like always have service worker on. It just won't be exposed to the web because it will still be in the Blink, experimental features flag. And we want to do this to like find any performance issues as soon as possible. So even if there's no service worker registered, like, did we degrade performance? It would be nice to know early on. Yeah, late May maybe would be like an intent to ship, and if that goes well, early June would be removing removing the experimental flag, and then in late June we expect is the M37 branch cut for Chrome, which would mean that if we make M37, it would mean it would be in Chrome stable in late August. And yeah, that's just kind of a target. It might be M38 or something like that, but that's like the schedule we had in mind. Okay. Yeah, so now I'll talk about kind of various risks that service worker face, and what we've thought about for these risks. Okay, the first one's performance. So our goals here is first to ensure that performance is not degraded when you don't have a service worker. So yeah, no perf regressions. The other one is, when you do have a service worker, performance is acceptable for, the users of service worker. So yeah, there's still discussion about, like what metrics and stuff to use. Like one might be like time the first byte for a response or something like that. But yeah, that's the basic performance story. In terms of compatibility, like Mozilla is also interested in implementing. The spec is being developed openly, GitHub, W3C. We're doing like there's always for these web features like the dance between the implementation and the spec, and we're taking a strategy this time of a concerted effort to write the W3C tests and get them okayed by the spec writers. So if something's like unclear in the spec, we can write a W3 test of what we expect to happen, and if the spec writer can say, yeah, I agree with that, and put it in the spec, or say, no, I disagree, update the spec to show the disagreement, and then we can fix our implementation. So that's the idea we have for compatibility. For security, yeah, all features go through security review, so that's the main gating factor of the security story. There's things like service worker only runs HTTPS only. This is to stop like a man-in-the-middle malicious injection of like a bad service worker that persists on your browser like indefinitely. So it's kind of not the best for web app developers to have to be HTTPS only, but we thought it's better for the users to be HTTPS only. A fuzzer, we're going to write a fuzzer to proactively find service worker crash bugs, security issues. Service worker obeys same origin policy, so that's part of the spec. And there's also things you can do like path restriction of where a service worker can come from, and a header for disabling service worker. So what this means is if you have like a college, like www.college.edu, and it has like all the users like /user/ like AAA, BBB, CCC. You don't want like user CCC registering a service worker that runs on everyone's URL. So one way to do that is like path restriction, or the server can put a header saying service workers not enabled, so the browser won't respect those. Okay. In terms of kind of complexity to the code base, so service worker is a type of web worker, so it's not like a totally new thing. The Blink code exists in modules/service workers, and it's actually not too bad in Blink. It's a lot of API entry points and bindings to pass over to the Chromium side, and a lot of like the meaty logics actually in Chromium, things like registration, storage, request intercepts handled by the Chromium code. And yeah, the integration with network stack is much cleaner than AppCache is. So I'm actually not too familiar with the network stack, but it's apparently better than AppCache. And I think the reason is that AppCache kind of says, oh, I have to cache this URL, blah, 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 and the network stack has to know about those. But with service worker, the browser just has to know to pass these events to the service worker instead of keeping track of that stuff. Okay. So yeah, this is not a risk. This is like kind of future work. So I don't think we're gonna end service worker like after shipping. So things like there can be new APIs built on service worker, as I mentioned before. There was a talk earlier today about that. The cache API I didn't talk too much about up till now. It can be exposed outside of service worker, for example, and maybe the service worker itself can manipulate that cache. Like the service worker registration and script persistence layer can be implemented using that cache, and the service worker can manipulate it to do like various things. there's things you can do with CSP and Service Worker, and I think there's going to be like a breakout session about that later. On us after this. Okay, great. So if you have questions about that, you can go to that breakout session. And yeah, I think that's okay. Yeah, I have some links here to find out more about Service Worker. You can check the slides online. Yeah, so the GitHub, BlinkDev, we have a Service Worker-reviews mailing list, so you can subscribe to that if you want to track like the implementation. And there's also like a nice like one-pager about Service Worker at the final URL. Okay, that's all I have. So I can open up for more questions now. Yeah.
So you said that we only support HTTPS to avoid the problem where if you man in the middle, you can have a persistent man in the middle installed. Yeah. So do we have any countermeasures where, because if you know, for example, with Heartbleed, someone could man in the middle for a couple of days whenever it was publicly mentioned. If someone would be able to install a Service Worker, then would anyone, you know, be able to work out and prevent this from ruining all of your websites you've visited?
Yeah, so let's see. So I think, yeah, the Service Worker is going to be limited to one origin, I think. And there's also things like there's the browser can also throw away like a Service Worker at any time. It's not guaranteed to live like all the time. We'll probably expose like UI to see what Service Workers are installed or anything.
There are also guarantees on how long the browser can wait before trying to refetch the Service Worker to look for updates. So you'll be guaranteed that at least once the man in the middle ends, that much time later, everybody will be up to your proper Service Worker again, and you'll flushed out the bad one.
Okay, yeah. So there's a limit to how often you update the Service Worker. So yeah.
There's like a maximum time you must try to update at least this often.
Okay, yeah. I was restating for the microphone. Yeah. Yeah. So there's a maximum maximum amount of time or of which the man in the middle can actually take effect. So when that's done, you will get the correct Service Worker eventually. Yes.
So the Service Worker can basically intercept a resource request. Do you enforce the same origin policy for that as well?
No. So the Service Worker can intercept a resource request. If that request came from a controlled page, the Service Worker can respond however it wants to that request.
So you can request from third-party sites and you will still intercept it? Oh, sorry. So basically, like if you have a Service Worker for Facebook.com, mm-hmm. Any request that Facebook.com, a page on that site does, will be intercepted by that Service Worker.
Yeah.
Like even if it's going to some Google.com or something.
Yeah, but like same origin is respect. So for example, if you have like an iframe, like you can't return something that will run in the context of Facebook.com.
Okay. Yeah. So you can't like have a Service Worker for Facebook.com that requests something from Google.com, and you modify that response to install a new Service Worker for Google.com and that kind of stuff.
Yeah. Yes, in the back. Yeah, so the question is if you have a request and the Service Worker like just doesn't. It takes like a minute to download that request. Like, is the site just frozen? Yeah, I mean, if the Service Worker doesn't respond, or if it's waiting, let's see. I don't think the site's frozen because the Service Worker is like running in a different context. But yeah, like you won't get that response for a minute, I think. Yeah. Right. If the Service Worker, yeah.
I think the question is if you can handle multiple requests.
Oh.
And I think the answer is yes.
Yeah. Okay. Yeah. So the question is if you can handle multiple requests in parallel, and the answer is yes. Yeah.
It's not necessarily in parallel, but like the event fires, and you resolve it synchronously with a promise that does the actual fetching, and then like the next event into the queue.
Oh, yeah.
I think that effect itself is not a
Right.
Not hanging the web worker thread. It's asynchronous itself.
Right.
Resolving costs.
Yeah. Yeah. So the fetch itself is asynchronous. So I guess if you have like some dumb service worker that sort of runs in this loop and never returns from the event, then you maybe have problems. But most of the stuff is async. Yeah.
No, if you don't, that doesn't work. On the event, you have to actually call respond with. If you don't call respond with,
okay,
it does the default action, which is going to the network.
Well,
and it's like the dispatching of an event. That's like
right.
Invoking the handler is sync.
Yeah, but if in the event handler you just say like while true and you don't do anything, then the browser will probably wait. Yeah. 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 So yeah, if you have something dumb, then something dumb happens. But it's made to not be dumb. Yeah.
About that, like one of the problems with AppCache was you get into a state where your page was just completely broken. And then some user somewhere has a broken version of your page, and you put the wrong thing in your manifest. So you talked a little about this a little bit. There's like a refresh on the service worker. Is that the escape valve here? Like your page will only be broken for 24 hours, or like?
I'm not sure I understand the question.
So my service worker responds hello world to every request.
Oh yeah, if you have a dumb service worker, yeah, then
Well, but that's one of the problems with AppCache. Like presumably your mistake was not.
If you had a mistake, yeah, I guess, yeah. I mean, you can force.
The biggest reason we have the 24-hour clock.
So, but you need to broken for 24 hours.
Yes, you'll. Yeah.
Okay.
For all your users, if you actually ship the thing that's set to all users, here's a service worker. It will reply hello world to everything.
Well, yeah.
Yeah, you can ship a new service worker on your server, and it will take 24 hours before all the users have like the newest thing.
Well, your document can also call register, which will trigger an update.
Okay.
So, yeah, there's ways to escape that.
Well, not if they already have a service worker which replies to everything with.
Oh, you're right. Yeah. Okay, then you are stuck. Yes, for 24 hours.
But as you said earlier, you can use some kind of HTTP headers to stop service worker.
Oh, right. Yeah. Maybe you can do that. Yeah.
Wait, but so what if you've been traveling for a week without internet? Does that mean that you can't access your offline content if you haven't been online in 24 hours?
No, the 24-hour thing is how long the browser goes, or the 24-hour thing means the browser will try to update the service worker script it has like once.
But it'll also refuse to use a service worker older than 24?
No.
Oh, just try to update.
Yeah, it just won't update it, but it'll still be using that thing. Yoshino-san. No, okay. Okay. There's still 2 minutes left. Any more questions?
A quick question. How about cache control policies in HTTP? Would that be if you set like permanent lifetime for service worker? The service worker script itself, what happens?
The spec talks about that, but I don't know exactly what happens. Maybe this.
It caps it to 24 hours.
So what if you have a cache in the middle? What if you have a cache in the middle? What is that one doing?
How can there be a proxy in the middle if it's delivered over HTTPS?
There are HTTPS man-in-the-middle proxies. This happens like virus scanners. If you have a virus scanner on your machine.
I guess you might be fucked. I'm not sure.
Yeah.
You're already HTTPS
All right. Yeah, in the back.
If the browser will check every 24 hours if service worker was updated, if that check fails, it keeps the service worker, then don't we now have browsers that will forever be making an increasing number of requests every 24 hours?
So if every 24 hours you're doing a request to see if there's an updated service worker, and a lot of those fail, does that mean that we'll have browsers doing these requests every 24 hours for a bad service? Yeah. Oh, yeah. I think there's some circumstances under which we might kick out a service worker, but I think that's also under discussion. Like, for example, what do you do with the 404? Do you kick it out or not? There's a big thread on GitHub about that. So, yeah, that's something under consideration. Okay, I'll end now. Thank you all for coming.